Alright, thanks for watching. First of all, my name is Derek Wells. This is for class ITD 1223 Network Systems, and this is my presentation on UDP, User Datagram Protocol. Alright, the basics. UTP is a layer 4 or transportation layer protocol. It is used in conjunction with IP layer protocol, which is why sometimes you see it noted as UTP/IP, similar to TCP/IP. It uses 8 bits in its header to identify packets going in and out, as opposed to 16 for the TCP. It's a little less popular. But there is some upsides and downsides to using UTP over UDP, over TCP. How it works. First of all, what's different with UTP over UDP, once again I apologize, over TCP is that UDP does not establish connection to the recipient. There's not a handshaking policy that happens that says, hey, I'm sending this packet to you. Are you the intended receiver? And then sending one back saying, yes, I am. So there's none of that going on, which is a little less reliable as far as the connection and sending the right packets. But this has its uses in other layers that we'll talk about later. It consists of, the header for UDP consists of 4 fields of 2 different bytes, so we get our 8 bytes total. The first 2 bytes is a source port. That is the port that the information is coming out of. Usually ports are assigned to widely used applications, like source port 23 is for Telenet, and some are for Ethernet and information protocols and things as such. Anyway, it uses the source port as the first 2 bits. The destination port is the second 2 bits. It obviously shows where these packets are intended to go. The third 2 bits is the UDP length. It's the header and data link, or the UDP length includes the 8 bits for the header and all the bits for the data that's encapsulated within it. That way that we can use the last 2 pieces, the UDP checksum, to verify that all of the information is there. It uses the third set of 2 bits to determine the length, and if the length is right, the checksum verifies, and it means that all the data was sent and everything is whole and nothing was missing in the transmission. One of the things about UDP is that it sends multiple datagrams, and those datagrams may not be in the right order. So there are certain applications that need those data sets to be in a certain order for them to piece them together correctly, and those applications do not do well using UDP. Usually they use protocols such as TCP or something else like that. Alright, some good things about UDP. Number 1 is the speed. It transmits data with less downtime in processing, reducing the latency of the connection. This is a few parts. This is because of a few things. One is because it has a smaller data tag attached to the header. Obviously it's only 8 bits instead of 16. It makes the file a little bit smaller. Not too much, it doesn't matter, but a little bit. There's no piecing together data packets when transmission of data is being sent. Everything is sent as one packet as a whole, and it's sent as groups, and it keeps getting sent. TCP will take that one packet and split it up into little pieces and send them in a certain logical order for the computer to then interpret. So there's no piecing together of data packets, which allows for a little bit faster speeds. It sends data using port numbers. We saw that in the first 4 bits of the heading tag that UDP uses. And like I said, in the last 4, it uses a simple checksum to verify all data transmitted is whole. So there is a check to see if the data that is sent is whole, but there is no check to make sure that the destination actually received the data. So if that's actually important to the recipient, that the data is actually sent, then you need to use another protocol, probably TCP or something else. Like I just said, does not verify the packet arrived to sender. It helps with latency, so there's no checksum, so it uses a little bandwidth on the network, so it allows for a little faster communication. Again, sacrificing reliability. It's used for smaller packets of data. If you want to transmit large packets of data, we'll be talking about in the next slide, this is probably not the best choice for it. Reliability is not key, UDP is key. So we're going to talk about some scenarios where UDP is actually preferred and why it's preferred. The first one is good for VoIP, which stands for Voice over IP, or gaming connections. These are usually used hand in hand. The reason UDP is good is that no, there is no checks and balances, but when you're using a program that requires things to be in real time, such as gaming connections, when the graphical interface and you're playing in an online environment where transmission of the data and as fast as possible is key, not so much reliability because you're sending the same packet over and over and over and over again with very little change. UDP is good for that because it would take too long to process if a packet wasn't received and you'd already be on to the next step. So as long as it just keeps sending and sending and sending, that UDP protocol is actually preferable to the TCP. Same thing with the voice over IP. There are certain programs that gamers use to communicate to one another. One is Ventrilo. It's one I personally use. And you use the voice over internet protocol to obviously send voice communications over the internet. Well, it doesn't really matter if those packets get sent and verified and are checked, because by the time it takes everything to get sent, to verify and come back, again, just like the gaming connection, we're already on to another voice packet, and there's no need to rearrange everything. So just the constant speed there is what you're looking for in that. One of the great things that UDP is used right now is for tunneling, and VPN stands for Virtual Private Networks. VPNs are getting more and more popular because of the security concerns that a lot of people have with the NSA and the TPP and TSS and certain personal private data things that are going through Congress right now. Anyway, these tunneling VPN services basically allow for virtual networks and virtual connectivity by placing one tunnel end in a network and placing the other tunnel end on a very, very opposite side of the network, and transferring those packets as fast as possible between those two connections. That way you can send off the packets through the end of the tunnel, which virtually masks your IP address. That way they don't know where the packets are going and coming into. So it provides that extra layer of security and anonymity that people are looking for. We talked about it would not be good for things like large data download servers. Like if you were to go onto Microsoft.com and want to download something, you would probably want to use TCP over UDP, because TCP A, splits everything off into packets, B, it establishes connection with your computer or device or whatever, the recipient as well, and C, you have such large data packets, and all these little data packets need to be transferred and make sure they are in a proper sequence to be used as a download. Obviously, the reliability of UDP is not used for that. It's better at transferring small amounts of data and not larger gigabyte, terabyte amounts of data. That's just would take too long, and the reliability of making sure all the data packets would not be there. Anyway, UDP does have its upsides as well as its downsides. It is good to note that the same system doesn't always have to use UDP, and doesn't always have to use TCP. They can be used simultaneously and used for different purposes into different port numbers. So when using or when deciding which protocol you want to use, go ahead and keep these things about UDP in mind. While TCP is overall a good connection, sometimes UDP works a little better. Thank you so much for listening. Have a great evening.